Welcome everyone to a Kuta worksheets tutorial. We are doing composite functions today. Now you'll see that the first question starts off right from the get-go with some composite functions. I'm actually going to start with page 2. I think it's a little bit easier to learn when you have some numerical inputs. So we're going to start with number 11. Now, with number 11, we have this little thing, and it looks like fog 0, okay? This doesn't mean fog. This little symbol right, let me highlight it. This little symbol right here means composite. Now, what is a composite function? It's like one thing fits into another, composite. We're going to do two operations. If we're going to do one thing, we're going to get an answer, and then we're going to plug it into something else. It's like two plugins, essentially. So we need to identify some things. First off, this whole thing right here can be rewritten as f of g of x. So that said f of g of x. That's how you say it. Okay, so if you look here, we're familiar with this. This is g of x. And then we have something on the outside too, and that is f of, and whatever's on the inside. In this case, it's f of g of x. As we look at this fog, f of g of x, f of g of 0, we're going to identify a few things. First thing we identify is we need to identify our input. Our input is always going to be the second parenthesis. So in this case right here, our input was this x. Down here, our input is 0. So this is important. This is our initial input. So we're going to say input for this. The next thing we identify is our inner function. Written in this way, it's kind of easy to see our inner function. Our inner function is on the inside. Here it's a little bit different. It's like, oh, where's the inner function? The inner function is always the one that's closest to the input. So this is what we call our inner function. I'm just going to write inner though. And then lastly, if we have an inner, we have an outer. This is our outer function. Just like we have here on the outside, the f with the parentheses, this is our outer function here. So this is the outer function. Okay, so two different ways to write it. If I were to write it in the exact same way with the input of 0, it would be f of g of 0. And that's how we would write that. But it means the same thing, okay? Now, what do we do with this? Well, if we had, you need to have some understanding of functions first. But if we had g of 0, what would we do there? All we would do is input 0 anywhere we see x in our g function. So there we see x and there we see x. And then we're just evaluating, that means trying to solve, for the function. So if I do that here, okay, you can see that, and I'm going to do this just so you can see that I inputted that 0. I'm going to change the color. Okay, I'm going to change the color of everything around it. Make this dark blue, okay? So you can see I inputted that 0 everywhere I saw x into that function, and then I'm going to evaluate. Now, when you evaluate, you're just leaving this g of 0. You're trying to find what g of 0 equals. This is our whole point. We're going to leave that alone because that's what it's asked to evaluate. And then we just solve on the right. So we do 2 times 0 is 0 plus 1. So we get g of 0 equals 1, okay? That's how we would do that. Now, that's our initial step, okay? So if we're going to list this in step form, I know a lot of my students like this. We start with our input. The input goes into our inner function, okay? We just did that. We did that over here, okay? G of 0. We inputted our input into our inner function. We are going to get a result. And yeah, let's put that in dark blue. So we get a result from that. In this case, we got 1. 1 was our result. Now, what do we do with this? Well, let me move this up. Once we get our result, we're going to input this where? Where do you think? Take a guess. Come on, go ahead, take a guess. Say it out loud. All right, I couldn't hear you, but I'm guessing you said outer. You input this into the outer. What does that look like? Well, we know f. By the way, I should have made this green, but oh well, sometimes, I can still change it. Look, style, and then I'm going to make it green. There, that way you can see a little bit more clearly, and then we're going to make this blue. Check this out. 0, 0, and then g of 0, that was our input. Okay, so now you can see that was our input and that was our result. And I'm going to change this to, sorry, I like color coordinating it because it just makes it a little bit more, makes it pop a little bit more to make it obvious what we're doing with each thing. So we got our result. Now we're inputting it into the outer, which we make in purple, not pink. Working on my color still. F of x equals negative 3x squared minus 3x, okay? But now we're not doing it for x. We're going to input something, not this input. We're going to take what our result was. So we're going to input the result from the inner function. We get f of equals negative 3 times minus 3 times, okay? And anywhere we saw an x, we're going to input that 1. So 1, 1, and 1. What do we do from here? Well, we're trying to evaluate for f of 1. Okay, this is our whole point. F of 1. That's what we want to find. Okay, and now what we're going to do, I'm going to keep it purple, but this is 1. Okay, we do order of operations. So first thing we would do is exponents. There's nothing to do in parentheses, so we move on to exponents. We get 1 squared is 1, negative 3 times 1, minus 3 times 1 is just 3. So we get equals to negative 3 times 1, negative 3, minus 3. That equals negative 6. Now, what does this become? We inputted our into the outer, and then we got something. We got a result, but this is going to become our answer. That is our final answer. So this negative 6, that is our answer to the composite function. Okay? So this is just like normal functions. Okay, this whole process right here is a normal function that we're familiar. There's just one more step where we're going to input this again into the outer function. Okay, so that's just kind of a way to break it down. Let's do maybe 3 more examples. Okay, let's move on to, I guess this one is a negative. Okay, so let's break this down again. So we have our inner function. No, sorry, that's our input. We have our inner function, h. So h is going to be our inner, and then g is going to be our outer. I chose our, yeah, okay. So I'm going to label that. So we have our inner, and we have our outer. Remember, inner goes first, outer goes second. And this is our input. So we start with our inner. We're going to do h of negative 3 equals, and anywhere we see an x, we're just going to change it from an x to whatever our input is. So we have negative 3, negative 3, negative 3. Now we just get our result. We work on this. H of negative 3 equals, negative 3 squared is 9, minus negative 2 times negative, or not minus, but negative 2 times negative 3 is positive 6. So we get 15. This is our result. Okay, what do we do with the result? Well, we're going to input this into our outer function now. We finished the first step. Now we move on to the second step. We're going to input this into g of x. So let me write g of x here. G of x, well, actually, let me erase this. G of negative 3 times plus 2. Now we're simply just going to take this 15 and we're going to input it right there. So let me copy and we're going to paste. I'm going to input it in for x. So instead of writing x, I am inputting this 15 because that was our result from the inner function, h of negative 3. Now let's solve this. So we get negative 3 times 15, that's negative 45, plus 2. Well, that gives me my final answer, negative 43, and that is my answer. That is the result from the dual process of inputting that function, okay? Now, something real quick in case you're wondering, g of g, what we're going to do is you're going to input 2 in for t. So you get 2 times 2 plus 5, that's g of 2. Okay, this would be our first step. We get 4 plus 5, 9. Now, we're doing this again in the same function. So we're going to go over here and input it into t again into the g function. So we get 2 times 9 plus 5. Oops. And that is g of 9. This is going to give us our answer. So we get 18 plus 5, and we get 23. And that would be our final answer for that one. Okay, that was a quick freebie. Now, I think these problems are actually tougher for most students. Why? Well, because everything's in terms of x. So if we take a look here, we still have our input and our output and all that stuff. So look this time, our input, looking at the composite function, this is our composite function, okay, written a little differently now. This is the same thing as f of g of x. It's the same thing, okay? Now our input, look at our input. That's not a number, it's just x. Maybe you think it's easier, maybe you think it's not. I think most people consider it harder. So there's our inner function, and you can see it's inner because it's on the inside of the parentheses. And then the outer is the outer because it's on the outside of the parentheses, okay? That's why it's the outer. So G is our inner. Let's go ahead and label it. Here we have our inner. And then here we have our outer. All right, now, what are we inputting? Well, we are inputting into our inner. Let me write it down real quick. So we're gonna write G of equals 4 of, or 4 times, okay? And anywhere we see an X, we're gonna write, what do you know? We're gonna write an X, okay? Our input is X. It literally stays the same. So that's the kind of like the easy part about it. The hard part is once you have to plug this in to our next function. Remember, we're going to take this and we essentially substitute it. That's a way to think of this, is substitution. We're going to substitute it into f of x. So f of, now this is where we have our blank, equals blank minus 5. This is where we take our 4x plus 3. We're going to take that whole thing, and that's what we're inputting into our f of x. Remember, this is our outer function. Okay, so that's our second step, is inputting it into our outer function. So I take this, input it anywhere I see x. That was this one here, in case you're wondering. That was where I inputted it. I think it's input, whatever. And now I'm just combining like terms and I'm solving. You're going to have an x. That's okay. We have 4x plus 3 minus 5. That is equal to 4x minus 2. This is our answer. No, we do not just get a number because it's in terms of x. Our input was x. We're going to have x in our answer, and that's how it works. Let me do one more just so we can see it completely. All right, here's a good one. So number 6, this is the one we're going to end on. So if you've been watching this, you're like, oh, when is this going to end? Very soon. That's my outer, that's my inner, and my input. I don't know why I went backwards, but I did. Our input is x. So essentially, we're just going to take our g of x, and we're not going to change it. G of x equals 3x plus 4. My result, essentially, is just the 3x plus 4 because I input x, which doesn't change anything. That's my result. I'm ready for step 2, which is input it into f of x. So f of x, I know, is, that's my outer function, f of, anywhere I see an x, I'm writing these parentheses, and I'm getting ready to input. So I'm going to take this 3x plus 4, copy, and I'm just pasting it. I'm substituting. 3x plus 4. Okay? Oh yeah, this one's a tough one. Okay, so 3x plus 4, that was my inner function, input into f of x. I'm glad we did this one because this is actually a concept you'll be learning in section 4.4 for those students that are taking this advanced topics course. But this is multiplying binomials, okay? So let me show you how this works. This is a little complicated. Glad I'm doing this one. Normally we have, pretty easy time. You simplify for x, yada, yada, yada. Now we have, it's just a little bit more complicated. We have this negative, and I like to do this anytime I have a binomial. This is a binomial, 2 terms, 1, 2. Squared, I like to write it out like this. 3x plus 4 times itself twice, 3x plus 4. And then I add that 3 at the end. This negative, I'm going to save for last. Okay, if you get this, you know how to do this, you can just stop this video right here, but I'm going to show you how to do this in case you don't know. What I'm going to do is I like showing the distribution like this. I go like this. I distribute the 3x to both the 3x and the 4, and then I distribute the 4 to the 3x and the 4. What does that look like? Well, I'm going to keep this minus out in front. I'm going to keep these parentheses right here. This big parentheses, and I'm going to do this plus 3. I do the 3x times the 3x, I get 9x squared. 3x times the 4 gives me positive 12x. Then I have 4 times 3x. That gives me 12x, positive 12x. And then I have 4 times 4. That gives me positive 16. Now I combine like terms inside this parentheses. Plus 3. Don't forget my minus out in front. I just wanted to highlight it. That's a little funky, isn't it? There we go. Like this. Okay, I want to highlight it just because it's important. So what do I get? I'm going to combine these. I'll put it in blue for some reason. 9x squared plus 24x plus 16. I'm going to distribute this minus now. This is the part that's important. Okay, I'm going to distribute this minus to all three of those things. 1, 2, 3. And this becomes negative 9x squared minus 24x minus 16. And then I have that plus 3 on at the end. What does that equal? I'm going to leave this 9x squared alone, minus 24x, and then it's negative 16 plus 3, that's minus 13. And this is my final answer. So that's why students think with x it's a little bit tougher, because you're always going to have an x. You have to worry about combining like terms, whereas numbers is a little bit easier. That's composite functions. I hope you enjoyed this video. Thank you for watching. Check out some of my Khan Academy tutorials on this exact same subject, and look forward to seeing you next time on West Explains Best.